An isometric. So we've now moved to the isometric object. We are talking about a 3D object, a 2D object, a 3D object, so that we know what this really is, right? So basically what we are talking about is we are going to be drawing things that we can even see. Even this house now, we can even draw it on a paper because we know how we can, at least we have a basis of how we can draw it from where we are getting it and where we are transferring it, right? So like I was saying, an isometric object is a graphical representation of a 3D object on a 2D plane. So for us to achieve drawing an isometric object or an object with 3 dimensions on a 2D paper, we have to do some sort of modification, okay, on the drawing. So obviously, a 3D object needs to have 3 axes, right? Get the point? Needs to have 3 axes. We have the vertical axis, the horizontal axis. It's very important that we use these things. A 3D object needs to have 3 axes. We have the vertical axis, okay, the horizontal, and another one here. So if this is Y, this is X, we need to have a Z axis, right? Because one axis will represent the length, the other one will represent the height, the other one will represent the width. Okay, so we need to modify the drawing now when we draw it here, so that we draw 3 axes that are going to meet at a certain point, and then we'll put one axis will represent the length, the other one will represent the height, the other one will represent the width. So when drawing here now, an isometric object has got axes that meet like this. Axes that meet at a point, okay? They're meeting at that point in this manner. So this is the modification that is there. So these axes that we are seeing here, they meet at an angle of 120 degrees with each other, okay? And another 120 degrees. So that's 360, right? So these axes meet at 120 degrees with each other. So these two here, okay, they are called horizontal axes. So this is a horizontal axis, and then this one here is called a vertical axis. If you were to draw a horizontal line, if we were to draw a horizontal line that is passing through this same point where the axes are meeting, horizontal line. Have you seen this horizontal line? It is passing through that same point. So this horizontal line will meet with this vertical line at what angle? 90 degrees, right? Yes. So meaning this angle here is 90 degrees. Even this one here is 90 degrees. 90 degrees, 90 degrees. But this angle here is 120, right? So 120 minus 90, 30. So here we are going to remain with 30, and here we are going to remain with 30. So 30, 30. So there is a horizontal line, 30, 30 there. This one is still 90. And even if we extend this 90 here, because it's just the same 90, we can even extend it this side, right? It will still be 90 with the horizontal. Understand? So what is that telling us? It is saying we can draw these 3 axes. I mean, 2 horizontal axes and 1 vertical axis can be drawn using, you start with a horizontal line, okay, which is this one, right? And then you pick a point on that horizontal line. You pick a point on that horizontal line, and then you draw a line at what angle? 30, right? And another line at what angle? And another line from the same point at what angle? 90. So these three lines that are drawn like this, 1, 2, 3, are called isoaxes or isometric axes. This is the basis for an isometric drawing, any isometric drawing for that matter. You cannot start drawing an isometric drawing without drawing isometric axes. Are we together? Whenever you've been asked to draw any isometric drawing, you start with axes. And these axes, 1, 2, the horizontal axis. 1 will represent either the length or the width. This is why you'll be measuring the length or the width of an object that you want to draw. Then the vertical axis will represent the height or what we call the depth. This point here, maybe we can call it point X. The point where the axes are meeting is called the lowest point. Okay? It's called the lowest point because when you look at a 3D object, it will be sitting on the surface where it has been placed. It will be flat, right? It will be sitting flat like this for a 3D object. But when you compare it to an isometric object, the isometric object seems to be sitting from each corner here. Have you seen this corner here? So this corner is what is called the lowest point. The basis of every isometric drawing is you identify the lowest point and then you draw the three axes. An isometric object is accomplished by drawing lines that are parallel to these three axes. Lines that are parallel to these three axes. If you consider this drawing that is here, I don't know if it has started making sense now. We can have this, and this as our three axes, right? Have you seen? Three axes there. And if you consider this line that is here, it is just a line that is parallel to this one. Okay? At a certain distance. So if you have a height, say, maybe, let's say the length is 20, this is 10, and the height is 5. Like that. Okay? So you start measuring from the lowest point. Listen. Start measuring from the lowest point. So from the lowest point you measure, what is the length? 20. So you come here, lowest point, you measure 20, right? Listen. What is the height there? 5. So from the lowest point, you measure 5. What is the width? 10. From the lowest point, you measure 10. Listen. At this point, you want to draw a line that is parallel to this one and a line that is parallel to this one from the same point. So you just come here, you draw that, you come here, you draw that. Listen. At this point and at that point, you draw a line that is parallel to this one, which will represent the height, right? So meaning these, they have to meet there. Even this one. Have you seen this point where the two lines are meeting here? We draw a line that is parallel to either this one or this one. We're just drawing lines that are parallel to the iso axis, right? So here, we just draw a line that is parallel to this, or maybe this one here. At this point, we'll draw a line that is parallel to this one. And there we have our 3D object represented on a 2D plane.